Chapter 11. The Fluid Universe. Air around us. Layers of atmosphere. Composition of air. Properties of air. Water for life. Drinking water. Chapter Air around us. The fluid universe is all around us. Air around us. Composition of air when layers we breathe. Of atmosphere. Properties of we cannot live composition of water for life. For a few minutes. Properties drinking of air. Water. All living things need water for life. AIR around us. The drinking layer water of air is all around AIR around us. Atmosphere. Air is all Earth's around. Gravity holds the atmosphere around the Earth. It protects us from the harmful rays ultraviolet radiation of the sun. The atmosphere also prevents meteors from hitting the surface of the Earth. The oxygen present in the atmosphere supports life. In places such as mountain tops or deep in seas and oceans where there is not enough air or oxygen, we need to carry oxygen cylinders for breathing. Air contains oxygen which is needed for burning. Inhaled or inspired air refers to the clean air we take in. Chapter 11. The air we breathe out universe. Is called exhaled or air around us. The blood in our lungs absorbs oxygen from the air we breathe in. Properties of exhalation, carbon dioxide from the blood is released. Drinking water. The amount of carbon dioxide in exhaled air is higher than that in inhaled air. It is also warmer than inhaled air. Layers of atmosphere. Earth's atmosphere has 5 major layers. They are formed by the air around the Earth and go up to several kilometers from the Earth. The density of air decreases with height. Air density is greatest at the surface and decreases as we move up in the atmosphere. The atmosphere is divided into 5 layers. Troposphere. This is the first layer above the Earth's surface. Humans live in the troposphere. Most weather changes occur in this layer. The fluid universe. The air gets colder air as you climb higher in the troposphere. Layers of atmosphere. Stratosphere. Composition of the second layer. Properties of air. Jet planes usually fly in this layer. Drinking water. Gas is present in this layer which absorbs harmful ultraviolet rays from the sun. UV rays can cause skin cancer. Mesosphere. This is the third layer. Most meteors burn up in this layer. Meteorites or the small rocks moving about in space burn out in this layer and therefore do not reach the surface of the Earth. Thermosphere. This is the fourth layer. This layer of air is very thin. Space shuttles move about in this layer. Many satellites orbit Earth within this layer. Exosphere. This is the fifth layer of the atmosphere that lies above the thermosphere and fades into space. The composition of AIR. Air around us. Air consists of a mixture layers of gases. Atmosphere. The air we breathe contains various gases. Properties of air. Clean air consists of water about 78% nitrogen, drinking water, 21% oxygen, and less than 1% of argon, air is all around, dioxide, and other gases. It also contains water vapor, dust and smoke. Depending on the surroundings, the amount of dust, smoke and water vapor in the air may change. Oxygen. The most crucial gas for the continued existence of living things is oxygen. All living beings need oxygen. Burning also requires oxygen. Nitrogen. Nitrogen is not directly utilized by living things. This nitrogen is provided to plants by soil microbes. Chemical fertilizers are also used to increase the nitrogen content of the soil. The fluid universe and flesh of animals are sources of nitrogen for animals. Layers of atmosphere. Carbon dioxide. Composition air also contains carbon dioxide which plants use to prepare food. Water for life. Carbon dioxide, drinking water and sunlight are used by plants to prepare their food. Air is all around. It is known as photosynthesis. Other gases, Traces of some other gases such as hydrogen, ozone, helium, neon, argon and krypton are also present in the air. Argon is a colorless and odorless gas present in air. It is used to produce the colorful glow in light bulbs and fluorescent tubes. Water vapor. Water vapor is formed because of evaporation of water from the surface of water bodies. Water vapor is the source of moisture for clouds, rain and frost. Water vapor in the air can cause changes in the weather. Chapter 11. The amount of water vapor present in the air is called air humidity. Around us. When there is layers more of water vapor, we say that the composition air is of air. When the air is dry, of air, we say it has low water humidity. For life. Properties drinking of water. AIR. AIR there is around air everywhere around us. Air is all around. Although we cannot see the air, it is present everywhere from an empty cup to an empty room. Let's read about the primary characteristics of air. 1. Air takes up space. Activity. Take a balloon and blow air into it. What happens? We will notice that the size of the balloon increases. This shows that air takes up space. 2. Air has weight. Activity. Take 2 balloons of the same size. Blow equal amounts of air into 2 balloons and tie them at the 2 ends of a hanger. Balance the hanger by shifting the positions of the balloons. Now prick a balloon and let the air escape from it. What happens? What does this experiment reveal? The stick tilts towards the air-filled balloon because of the weight of the air inside it. This experiment shows that air has weight. 3. Air exerts pressure. Air pressure is the force with which air pushes against the Earth's surface. Air has density and mass. Due to its mass, it puts pressure on the things around it. The pressure of the air decreases as we climb a mountain. We make use of air pressure in a doctor's syringe for filling in liquid medicine, filling up fountain pens, droppers, or sucking liquid through a straw. In each of these cases, we first squeeze out the air. Only then does the liquid starts flowing in. 4. Air exerts pressure in the upward direction. Activity. Take a glass tumbler and fill it with water to the brim. Make sure that there are no air bubbles in the tumbler. Cover the tumbler with a stiff paper. Turn the tumbler upside down while pressing the paper with your hand. Take your hand off and look around. What happens? What does this experiment reveal? We see that the paper does not fall and water stays in the glass. The air pushes the paper up, i.e., exerts pressure in the upward direction preventing it from falling. 5. Air exerts pressure in the downward direction. Activity. Make a hole in the side of an empty plastic bottle. Seal the hole with sellotape and fill the bottle with water. Open the hole and observe what happens. Seal the hole again and fill the bottle with water. Screw the bottle cap on firmly. Open the hole. What does the experiment show? We will see that the water will come out of the hole because air exerts pressure in a downward direction. 6. Air exerts pressure in all directions. Activity. Take a tin and boil some water in it. When steam begins to come out, cork it and stop heating it further. Put the tin in a trough and pour some cold water mixed with ice on it. What happens? What does the experiment show? We will observe that the tin gets crushed and becomes irregular in shape. This is because the cold water condensed the steam inside the tin to water. This left no air inside the tin. Thus, the pressure inside the tin became much lesser than that on the outside. The air pressure from outside acted on the tin from all directions and crushed it. This experiment shows that air exerts pressure in all directions. Atmospheric pollution. Air contains particles of dust, smoke and harmful gases. They are called atmospheric pollutants as they make the air dirty and polluted. These substances accumulate in the air to a degree that is harmful to living organisms or to materials exposed to the air. Burning of fossil fuels, gases released by automobiles, factories and industries release smoke and harmful gases in the air which degrade the quality of the air. The Air Quality Index AQI is used for reporting daily air quality. It tells us how clean or polluted the air is, and what associated health effects might be a concern for us. The AQI for 5 major air pollutants regulated by the Clean Air Act: ground level ozone, particle pollution also known as particulate matter, carbon monoxide, sulfur dioxide and nitrogen dioxide. For each of these pollutants, Environmental Protection Agency (EPA) has established national air quality standards to protect public health. Atmospheric pollution is a big threat which leads to a number of respiratory disorders and heart diseases among humans. It also leads to global warming. Water for life. Air and water are equally vital to human survival. About 71% of the Earth's surface is covered with water. It is found everywhere from oceans to lakes to ground and even in the sky as water vapor. We need water to carry out our daily activities. We need water for drinking, cooking, bathing, working and construction work. Plants too cannot live long without water. We cannot imagine a life without water. Rainwater is the main source of water on Earth. Impurities in water. Substances such as mud, sand, dirt and germs make water unfit for use. These are called impurities. Impurities are of two types: soluble impurities. Impurities that dissolve in water are called soluble impurities such as salt. Insoluble impurities. Impurities that do not dissolve in water are called insoluble impurities such as sand and mud. The water in wells and rivers is impure due to a. Insoluble impurities which can be seen. b. Soluble impurities which cannot be seen. C. Disease-causing germs. Solution. A solution is a mixture in which substances are completely dissolved. It can be defined as a special type of mixture where two or more substances are combined in such a way that they evenly spread and mix with each other. The two substances that make a solution are solute and solvent. Solute is the component of the solution which is present in small amounts, whereas solvent is the component of solution which is present in large amounts. Let us take an example to understand about solute and solvent. When we mix salt and water, it completely dissolves with each other and forms a solution. Here, salt is the solute and water is the solvent. Removing insoluble impurities. Different methods are used to remove various soluble and insoluble impurities from water. We can separate the insoluble substances from water by sedimentation followed by decantation and filtration. Activity. Collect impure water containing mud in a beaker. Stir it well with a glass rod. Allow the mixture to stand for a few minutes. The heavier soil particles will settle down at the bottom of the beaker. These are called sediments. This process of separating insoluble substances is called sedimentation. After the insoluble sediments have settled down, now carefully drain the clean water into another beaker. This is called decantation. We can also separate the mixture of soil from water by using filter paper. This process is called filtration. It is a process in which water containing insoluble substances are poured into a funnel having a cone of filter paper. Insoluble substances are caught in the filter paper and the clear water passes through it and gets collected in a vessel called a filtrate. Removing soluble impurities. It is more difficult to remove soluble impurities than insoluble ones. We can separate soluble substances from water by evaporation and distillation. Evaporation, the process of changing of water or any other liquid to vapor by heating, is called evaporation. In this process, the soluble substances can be separated by heating the water liquid. When all the water evaporates, we will get the substance. Water is lost during the process of evaporation. Activity. Take some water in a beaker and dissolve 2 teaspoons of salt in it. Take some of this salt solution in a dish and heat it. We will see that water evaporates, leaving behind salt particles. Distillation. Distillation is a method which separates impurities from water. This method of purifying water generally performed in laboratories. In distillation, impure water is heated till it starts boiling. On boiling, the water evaporates and the impurities remain behind. The water vapor enters the condenser, which is kept cool by the cold water circulating around it. On entering the cool condenser, the hot steam or water vapor changes into water again. It collects in the flask below. The water collected after this process is called distilled water. It is free of any impurities or germs. The impurities that were dissolved in the water are left behind in the heating flask. Thermometer. Distilling flask. Burner. Water vapor. Water out. Condenser. Receiving flask. Pure water. Cool water in. Drinking water. For a healthy living, clean water is necessary for drinking and cooking. Drinking water needs to be purified before consumption because impure water contains many disease-causing germs which can lead to a variety of diseases such as cholera, jaundice and dysentery. In large towns, the water supplied to the public is purified and filtered before being piped for domestic use. The methods are mainly used for treatment of water. Screening. Screening is a wastewater pre-treatment. In this process, the water is taken from lakes, rivers and passed through screens that remove large impurities like stones, leaves, plastics, etc. Sedimentation. It is a process that removes solids that float and settle in the water. Water collected in large open tanks is left undisturbed for a few days. This way the heavier suspended impurities settle down at the bottom. Air and sunlight kill many harmful bacteria. Chemicals like alum are also added to purify the water. Filtration. After the process of sedimentation, the water is filtered through sand beds to filter out finer suspended particles. Chlorination. Next, chlorine is added in small amounts to disinfect the water. The water is now safe for drinking. Synopsis. Earth's gravity holds the atmosphere around the Earth. The 5 layers of atmosphere are the troposphere, stratosphere, mesosphere, thermosphere and exosphere. Clean air consists of about 78% nitrogen, 21% oxygen and less than 1% of argon, carbon dioxide and other gases. Air has weight, occupies space and exerts pressure. Water can be purified by sedimentation and decantation, filtration, evaporation or distillation. In large towns, the water supplied to the public is purified and filtered before being piped for domestic use.